The air conditioning system utilizes two identical cooling packs that provide conditioned bleed air for cabin heating and cooling. The packs include the following components: dual heat exchanger, air cycle machine, condenser reheater, water collector, add heat bypass valve, and temperature sensors. There are also two external components: the pack bypass valve and a pack flow control valve, which together control pack operation. During normal operation, each cooling pack provides half of the total fresh airflow. However, a single pack is capable of providing 67% of the total flow and ensuring safe aircraft ventilation and temperature control capability. Hot air from the bleed system, controlled by the flow control valve, is pre-cooled in the dual heat exchanger, using cold ram air to remove the heat. An air cycle machine within the pack contains two cooling turbines to generate cold air. The pack also contains an internal condensing water collection system to remove moisture. Finally, the required duct temperature is maintained by mixing pack outlet cold air and pack bypass hot air. The pack flow control valve is located upstream of the left and right air cooling packs. The valve is torque motor controlled and modulated by the AMS controller, but has a pneumatically actuated butterfly valve. It incorporates a closed position switch to provide position feedback to the AMS controller. A filter removes air supply contaminants. A locking screw installed in the actuator housing can be used to lock the valve in a closed position. The valve operates as follows. The flow-sensing Venturi differential pressure signal is sent to the AMS controller for calculation. For internal calculation, the AMS also uses the manifold bleed pressure and the pack inlet temperature to determine airflow to the packs. The controller millivolt signal is sent to the flow control valve to define the valve position that will modulate the airflow. The flow-sensing Venturi is a steel duct. The Venturi contains pressure-sensing ports on the upstream and downstream side of the duct orifice. Airflow across this duct is measured by a differential pressure sensor mounted on the Venturi. The sensor provides a 0 to 10 volt DC electronic signal to the AMS controller. The sensor is hermetically sealed and has two input pressure ports, an internal pressure transducer, and an electric connector. A dual heat exchanger and a fan inlet diffuser housing assembly are installed into each ECS pack. The primary circuit removes heat from bleed air before entering the compressor section. The primary section is a single-pass cross-flow configuration. The secondary circuit removes heat from the compressor outlet air before it goes towards the reheater. The secondary section is a two-pass cross-counterflow configuration. Both bleed circuits are cooled by ram air in series. First the secondary, then through the primary heat exchanger sections. Ram air exiting the heat exchangers enters the fan inlet diffuser housing and is either pulled through to ambient by the fan or passes through the fan bypass check valve. The heat exchanger contains access windows for inspection and cleaning of the heat exchanger ram air circuit. The air cycle machine external structure has three components: fan and compressor housing, first stage turbine housing, and second stage turbine housing. The internal structure incorporates two turbine stages which drive a compressor and a cooling fan. The 4 rotors turn as one assembly, locked together in the common shaft. The assembly rotates on hydrodynamic foil-type bearings. The system uses no oil and requires no scheduled maintenance. The air cycle machine compressor will raise the air temperature and increase pressure in order to provide more effective cooling on the turbine stages. On the turbines, the air is cooled by expansion, and part of the thermal energy will change to mechanical work to drive the compressor and the fan. This will cause significant temperature drop across the turbine stages. The fan draws ambient air across the heat exchangers to provide cooling flow at static ambient conditions. The air routed to the condenser reheater first passes through the hot side of the reheater and is then subcooled in the condenser, using the first stage turbine exhaust air as heat sink. The cooling process condenses water collected by the downstream water collector. The collected water is sprayed into the ram inlet of the dual heat exchanger to improve the heat exchanger performance. The condenser reheater is an aluminum dual heat exchanger. The pack bypass valve is installed parallel to the air conditioning packs. It is a butterfly valve powered by a pneumatic actuator. The valve maintains the required hot airflow to the pack outlet, as directed by the downstream duct supply temperature sensor output, which directs the pack controller to modulate current to the valve's torque motor. The valve position is controlled by the pneumatic servo pressure generated by the torque motor. The valve can be locked in the closed position by removing the lock bolt. The low-limit bypass valve is an electrically actuated valve installed in the air cycle machine turbine housing. The valve limits condenser inlet temperature to a minimum of 34 degrees Fahrenheit, 1.1 degrees Celsius, up to 25,000 feet, or to 50 degrees Fahrenheit, 10 degrees Celsius, above 25,000 feet. A linear actuator is used to rotate a piston that meters the amount of warm air bypass flow in order to control condenser inlet duct temperature. The downstream duct temperature is used as feedback for positioning of the valve. The AMS control logic is based on bump, stop, check, and the signal is sent to the actuator to extend or retract in steps. A knob on the linear actuator housing permits manual valve position adjustments. Each air conditioning pack incorporates an on-off add heat valve, which supplies warm air from the compressor outlet to the condenser inlet. This is used to maintain a minimum turbine inlet temperature of 60 degrees Fahrenheit, 15.5 degrees Celsius. The add heat valve is controlled by the AMS controller as a function of ambient temperature and altitude, and is opened and closed using a solenoid. The air conditioning pack temperature control has 5 temperature sensors, which supply data to the AMS controller. The sensors are pack inlet temperature sensor, compressor inlet temperature sensor, compressor outlet temperature sensor, condenser inlet temperature sensor, and pack outlet temperature sensor. All of these sensors are dual element sensors, except the pack inlet temperature sensor, which has a single element, in order to improve system reliability. The AMS controller monitors all sensor voltages in order to control pack operation or determine pack failure. Bleed air passing by the pack inlet temperature sensor and through the primary heat exchanger enters the air cycle machine compressor. Compressor inlet and outlet temperature is sensed by temperature sensors and forwarded to the AMS controller. The main flow from the compressor goes through the secondary heat exchanger and on to the condenser reheater. Some hot air is tapped and directed to the add heat valve to maintain turbine second stage inlet temperature. Air from the condenser reheater is directed to the first stage turbine. where the temperature will drop. The low-limit bypass valve is installed parallel to the first stage turbine. The valve provides additional warm air to maintain condenser inlet temperature. Air flows through the condenser and enters the second stage turbine for a further temperature reduction. Turbine outlet cold air is mixed with pack bypass air to achieve the requested duct temperature. The pack-related ICAS messages are: pack fail caution, if any pack component develops a fault. Pack off advisory message, if the pack is switched off. Or pack leak caution message, when an overheat is detected in the pack high-pressure bleed duct. CMC messages will be provided to determine failed pack components, if the pack fail message is present. The pack will be disabled in the following conditions: bleed source not available, pack switch is off, left or right engine start with weight on wheels, duct leak, or if the AMS built-in test detects failure.